Okay, I'm gonna first of all, I'm recording this to a video file because it is the WhatsApp video is too small to work with. Okay, so it's I'm having to put up too many videos, so I'm gonna do one big one and upload this, and you can take it from there. Right now, I've also opened up this in Notepad because trying to navigate through Visual Studio is proving too slow, and therefore it's taking up too long to run. Uh, Scroll through the code, and therefore it's creating too many videos. So I'm going to have to work around that problem by opening up in Notepad, and it's the same code. Okay, so that there, as I said before, that there is using the Tweet INVI package. Okay, these are some other built-in libraries which are needed by the application. The that one there, system compression, the tweet data gets compressed into a small file. So I do that there. Okay. Uh, Nothing else there you really need to worry about. The text opens up different files, and so does that there, using system input output. Right. Everything else is specific to other tasks. We don't need to go into that right now. It's not really that important. Um, this here This here is the user credentials for the Twitter API. Though, as I said, those details there are specific to my account. We can try and get those details for your account at a later stage, but it's really not necessary at this time. They are completely untraceable back to my account, and in the event that they wanted to investigate further, they would have to get paperwork and petition the company for details of the account behind these user details. I don't think this is that big a project that would justify such an expense of time and effort to find that information out. So therefore, I think you would probably be okay putting these credentials in, which you could say they are yours or they are a friend of yours. That is very easy to do. I don't think it's an issue. But that's where it sets the credentials for the Twitter accounts. Okay, that is what that does, and there's a number of them. You don't need to go into what they do. There's four of them, and there's a key, and then there's API keys. Okay, but essentially they're like passwords into the Twitter account, right? This here is when we want to get a tweet for one city. We go the search parameter. It goes new tweet INVI, so it's putting them into the package, the parameters, and you're going to put in. Now, the hashtag will be contained in text box 1, which is on the screen, and it must contain hash, which I'm putting in there. So you put in a hashtag, but that's the format that the Tweet INVI package expects a hash above that, so you must put that in, right? Then it sets the geocode for the tweet. So you want to get the tweets in and around this latitude and longitude, which we're feeding in as a parameter of the function. So when we go get one city tweet, we will get the city, which, let's say in the case that was Los Angeles. If you look at the earlier video, you see that there was the name of a city, then there was the latitude and the longitude, and the X and Y were specific to the user interface of this application. Those X and Y coordinates there do not go into the Twitter API. You will need the latitude and the longitude. So you feed in the latitude and the longitude into the Twitter API via the Tweet INVI package. The latitude and longitude, let's say for Los Angeles, and you want all tweets with a 500-mile radius around that city, right? And that's the distance measured in miles, which defines that that's 500 miles around this latitude and longitude. Note, you don't put in the city name, you only put in a latitude and longitude, okay, for anywhere on the planet. The Tweet INVI package and the Twitter API in particular does not recognize a city as such. It only recognizes latitude and longitude. That's why we had to fill out all the latitudes and longitudes for the cities on that list, right? And I got them from sources on the internet. They were not provided by the Twitter API, so we had to create them ourselves. They are specific, like I do have the Los Angeles latitude and longitude exactly correct, right? And they are all specific, right? So there, and we're filtering only for English there. So you could theoretically, at a later stage, and you may want to mention this, it could be modified for different languages. So let's say you wanted to get all the iPhone tweets in English, you wanted to get all the iPhone tweets in French or German. You can specify your language here as well. So it's unlikely that you would have many German tweets in Beijing, right? Nevertheless, some people may want to use that. So you could say that it could be expanded, right? Now, at the moment, I'm getting one result per city and building up those results over time. So we have a number of iPhone tweets from the same city over a period of time, and that's why we're storing them, right? That's there. And then we go for tweets. So that says put all the tweets. We search the tweets with the search parameter. So the search parameter has been defined here with longitude, latitude, 500 miles, and then the actual tweet itself. Then we get back one tweet by feeding in the search parameter. So this is code, right? If the tweets is null, then you just go back, and then we've got to scan through all the tweets here, right? So this is where we get the tweets back, right? And so you'll get T is the tweet, right? So it'll be who created it, etc. New line, the local creation date, the text of the tweet, and then this is where we get the sentiment. We get the text of the tweet here, then we clean it, which is really just taking out some various different characters that we don't need, that the Microsoft Azure API doesn't like, and that's where it gets cleaned there. All right, I'll come back to that in a second. Then we get the sentiment. Then we get a sentiment score, which gets returned in this function. Then we add the sentiment to the output string. The key phrases that were instrumental in gaining that particular sentiment, the Microsoft Azure API returns those key phrases, and that's comes back in a global variable, which we then append here. The coordinates were the longitude and latitude. Again, I'm picking it up from what we put in. The coordinates we fed in takes care of that, right? Hashtags, there may well be other hashtags as well as the hashtag that you put in, and they get displayed here, right? Environment new line is just simply carriage return new line for the text. An ID is the ID of the tweet. They vary, and they're the massively big numbers, and then the place wherever it was, LA or wherever it is. Okay, so that again gets appended to the text box, text tweets dot append text. Then we plot the dot, which is XY, which is the coordinate on the picture box, right, lower down on the map, right? And then we set the color here, right? And then we store the tweet, right, which is another function in here, right? So I'll come back to them in a second, right? So that's where we return the tweet, depending on the tweet score. Like we get the sentiment back, right? And depending on the sentiment number that we get back, then we will set red, orange, or blue. So if it's less than 33, and you know, if it's greater than 33 and less than 66, then you will get orange, and that's what defines the color of the dots. If we get nothing back and there is no sentiment and it doesn't fall into any of these brackets, then it will simply be black. Sometimes there is no tweet for a particular city, and sometimes you will get a black box, right? That's where we clean the data that comes back from the Twitter API, and these characters have been removed because they are not wanted by the Microsoft Azure API. Nevertheless, the Microsoft Azure API will clean it further based on its own internal algorithms, which you could investigate on another day if you wanted to. At the moment, we're just putting in a random sentiment because it's not necessary, because every time you send in a tweet into the Microsoft Azure service, you have to pay for it, and all it does is return a number anyway. So I have that put in temporarily. It's perfect for our purposes, and the code doesn't really have to change that much at all. That one there is clears all the tweet data from our file. I'm not really implementing that at the moment. I'm pretty much storing everything, right? Now, this is where we get the actual sentiment for the Microsoft Azure API. The sample text is the tweet text that we're feeding in. We have an API key, which is the password into the Microsoft Azure services account. These URLs are the URLs that we will use to pass the tweet into, so that the sample text from the tweet is fed in as a parameter into the URLs, and then the information is returned from those URL calls. A lot of this here is pretty much code that interacts with the Microsoft Azure services account, right? So you've got these are all, it's just code. It's very detailed code on how it interacts with these. I really don't want to go into too much right now because it's going to take all night to get into the details. That's roughly what it does, is that it's interacting with the Microsoft Azure Services API. Okay, so that's why it says Northern Europe API.cognitive services, Microsoft.com, etc., etc. Key phrases, sentiment, and languages. So that interacts with all of that, and at the end of the day, it returns the key phrases and the sentiment score right there. That's what it does, and that's what it's supposed to do. All of that is very specific code, so I'm not going to spend too long on that. That's where we load the cities into the list box on the right hand side. When you see all the cities, they get loaded in. That's actually when we're searching for the tweets on the screen, on the lower down on the screen, when you want to search them, that just gets loaded in here. That's just C# code there to do that. That's when we load up the form. I said that to you before. That's where all the cities get loaded in. There's the longitudes and latitudes for all the cities. So Sydney is -33 and 151, their longitudes and latitudes, and that there is its position on the picture box in pixels, right? Load from there, set up the list view, which will display all of the tweets, the list view box. That then takes all of the so I want to store a tweet. We feed the tweet into here. The hashtag that we use to search for this tweet, the city, who created it, when we get all this stuff back, the local creation date, etc., etc., all of these details, which go right to the end here, including the global key phrases, the longitude and latitude that the tweets was from, the ID, etc., that we got back from the Twitter API, all of that gets stored, right? So what we have here is the date and the time, because we're storing it now. We have the dates it was stored, the date stored in a string format, so I can more easily manipulate the data. We have the hashtag the user searched on for this particular tweet, so that's the hashtag search from user. The city, okay, could be LA or wherever it may be, created by, who created it, and all of that there, all the way down there, gets stored. The tweet data rows.add, so add one row to the tweet data. That's the tweet data store. This here is when we load the tweet data store from file. You have to create a buffer, then you read all the bytes from the path. The path is the path to the file. You then decompress. We have to decompress the buffer, so that gets loaded into a buffer, it gets decompressed, and then we just turn it into a file and we return a table. So the file is decompressed and then it is basically just an internal memory table, so all of the details are then held in memory in a data table. So it loads from file, but that's its return type, which you always have a return type in front of the function. So it's a data table. So it's like a grid in memory, a regular grid, but it's held in memory of the application, so then we can access it as if it was a database table in memory. That's what it is, okay? So a data table format deserializes the stream. So the stream comes in from a file and then it gets decompressed, and that's how I'm doing it, because it saves a lot of space, because the tweets could get quite big. That's where we want to save it to a file. There are compression functions that compresses the stream when you want to write out the file. You want to compress it before you save the file, and this is when you read the file in, you must decompress it. So that's what that does there. When you want to save to a file, there's the data table there. That's the internal data table that we have. Let's say we've got it here and then manipulated it and added rows to it, right? This is it going back out again, right? And that's it going back out to the path, right? So we have it has to compress it again. So we're compressing the data table and then sending it out to a file, right? Right, and that's what I'm doing there. I went over, that's now that gets one city tweet from the storage. You put it you feed in the city that you want, the latitude and the longitude and the X and the Y, and this will come in and it will get it from the storage. So it will look through the tweet data table and it will search through them all. So 4i is equal to 0 to the number of rows, the count. If the city is equal to the city that we're looking for, and the hashtag the search on is what we're looking for, then get it out of storage, get the sentiment that we've stored in there, and return that, and that's what we do there. Okay? And that's pretty much it. Okay, so that's about it. As far as algorithms are concerned, there are a lot of algorithms in it. Let's say when you're trying to decompress the data and compress the data, there's algorithms used there. I mean, I can't go into the details. It would take all night to explain exactly what's going on with that, and there's a lot of code in here as well. I can try and come back to you if you specifically want to know that. They're just empty functions. That's the loading the distinct hashtags, where we go into where all the distinct rows from the stored tweets, we have to get the distinct hashtags out, and that's what that code there does. It's not a C# tutorial. I mean, we could be here all night going through how C# works. This is just a general overview which you can put into your presentation. That's pretty much it there. That's all you need to know. Okay, I've been over everything there, so that should really do it there. That was some function I put in. We don't need to use that anymore. I just left it in there, but it's not needed. And that's about it. That's just when you want to load the cities in. So we want to, if we want to select a particular city, they go into the lower box for the search when we're searching the stored tweets. So that's what that does there. For I is equal to MX. MX is list box. The list box 1 contains all the cities. So you go for I is equal to 0 to the number of cities. Just add them all in there. And that's what we're doing. I'm getting the name of the city out there. I'm just parsing the text. And that is a loop. And then it will just it'll add those city names to combo box 3, which is another combo box lower down, so that we can select the cities for when we're searching the stored tweets. And there's all the cities again with the longitude and latitudes, and you store the tweet. And that's pretty much it. That's when we plot the dot. We have X and a Y and then the color, and then we will go create a point, so as location, point at XY on the picture box, and we set the color to be C, which we've just fed in. It could be any color though, depends on what we want. You make it visible, you set it to a particular size, which I have at 5 by 5. So there's those little boxes which represent the cities on the picture box. They are set to a size of 5 by 5. Bring it and then the update. So that's just that's C#. Okay, and that's there. That's saving it to a file there, where we save the data table to a file, and it gets compressed and then decompressed. That's the code for compressing it and decompressing it, and that's it. I think I've gone over everything there. You should have enough then. There are no main algorithms as such. I mean, algorithm is when you're parsing specific things. What we're doing is just getting the tweet data and displaying it. So I wouldn't call what we're doing, the algorithms are more built in to a lot of the C# functions already. We're not really running algorithms in a sense of parsing the data or doing any number crunching. You know, if you're doing maths number crunching, you have to write algorithms for that. We don't need any algorithms. What we're doing is we're going to the Twitter API, we're getting the tweet back. That's not an algorithm. That's just gathering the data mining. Then we're feeding that data into the Microsoft Azure to get the sentiment, and then plotting the sentiment. So the whole application is one big algorithm where it goes, it gets the tweet data, then it feeds it into the Microsoft Azure services, which we showed all of those links. Then it gets the sentiment back and then plots the sentiments and stores the tweet. So the whole application is one big algorithm from that point of view, right? How it works, right? Yeah. So that's it there. Okay, so if you need any more stuff there, I'm going to send this video now, and that should do it.